We are at the campus of Center for Environmental Planning and Technology, called as CEPT. And CEPT is one of the most reputed architectural institute across the world. And I have with me Mr. Anand Patel, who is a very renowned and reputed architect. Mr. Patel studied in Netherlands. He studied architecture over there and then did his philosophy over there. And he has almost 30 years of experience in this field. He started his own practice in the year 2009. In 2020, you joined SCP as a consulting architect for government projects, or public sector projects rather. He is also visiting faculty at CEPT. He has taught in Berlin, he has taught in Vienna, he has had his practice in Europe and India. And now that you all know Mr. Anand Patel, I'm going to show you something very amazing and take this interview to the next level. So let's do that. Okay, this is what I wanted to show you. What you can see over here are two beautiful, gorgeous buildings which are built within the CEPT site. Anand bhai, what was the purpose of these two buildings?
So these are meant for studios. Studios are the system in which courses are taught at CEPT. So in a design school, in a regular college we call classrooms.
Okay.
In a design school, a unit of a classroom is known as a studio.
Okay.
Because it is design based learning. So an average studio here is about 16 students and 2 tutors. So a unit of 18 people makes one studio, academic year studio. And students sit in a group, and each of these studios, these buildings, this one houses 8 studios and the other one houses 10 studios.
Okay.
So roughly about 320 people can sit here and study.
Right.
Yeah.
Okay. So when you were designing these buildings, were there any functionality aspects or certain features or aesthetic aspects that you had to keep in mind?
Oh yes, absolutely. See, one foremost thing is any building has to be comfortable for the function that it is being made for. So in this case, the buildings are being made for students to sit here and study.
Right.
Or basically do their design exercises.
Right.
So the space has to be conducive to that.
Right.
It needs to have that much of freedom of movement. It has to have volume. It has to have a good amount of light. It needs to have a good amount of ventilation, whether natural or mechanical.
Right.
It needs to have a good amount of artificial lighting when it gets dark in the evenings.
Right.
It has to be safe from fire, from the weather. So all of those things play a very important role in designing this.
Oh, okay, all right. Now I can see that these are pre-engineered steel buildings.
Yes.
I'm sure that you have a lot of building technology options with you.
Yes.
So why did you only go ahead with pre-engineered building?
Yeah, interesting question. The reason for choosing PEB here is one, we wanted these buildings to be made very fast.
Okay.
Second is that these are large span buildings. They're about 60 feet in width without any supports in the middle.
Right.
So to do that in concrete is difficult.
Right.
Or is just much heavier.
So you have columns in between.
So you would have columns in between. So in this case, we don't have any columns in between. It's a single span. And also because it can be built very fast, we opted for this system.
Okay. So this is one parameter I can understand the speed, but then there are also other parameters like, say for example, cost being one of them.
Yes.
Then you have the longevity, you have the maintenance, you have the sustainability aspect and so on and so forth. So how do you compare PEB on all these parameters vis-a-vis the other technology options available?
Yes. So cost, of course, is a very, very important factor in any building project. We did the cost analysis and we figured that the end cost of doing this project with any other material or with steel is almost coming to the same.
Okay.
The only advantage we have with this is the time factor.
Right.
So what would normally take a year and a half or two to build, technically we could do this in 6 to 8 months. So you save a lot on time. So that is your saving in terms of also your investments, and so there is a cost saving in terms of time.
Okay.
Yeah.
So that's basically the opportunity cost that you are saving.
Yes, absolutely.
Okay, all right. So one question on PB,
Yeah.
that sustainability aspect. Of course, I mean, I'm sure that going forward, that aspect is going to be more and more important in
Yes.
every industry, every building that you are going to build. So how is this building, contributing to the sustainability aspect?
See, one is the steel is a highly recyclable material, as we all know.
Right.
Steel, however old, can still be recycled. So one great advantage of having a building like this is, let us say it passes its life cycle. This entire amount of steel that is there can be fully recycled. So what, say you have invested in X amount of steel, so many 100 tons,
Right.
you derive the same amount of tonnage of steel once you dismantle it.
Right.
Unlike in a concrete construction, where you may be able to salvage the steel out of the reinforced concrete,
That's about it.
but the rest of all the concrete has to be thrown away.
Right.
So that is the big advantage you have with building in steel.
Right.
Yes, so that's about recycling. So now let's go inside and I'll show you how we've
Oh,
done
that's
it.
wonderful.
Yeah,
Let's go.
please come, please.
Thank you. Thank you. We are inside this beautiful CEPT studio structure. Anand bhai, can you tell me how many days, I will say days, did it take to complete this entire structure?
So, I mean, there are two parts to it. One is the civil construction part, which
Right.
is the foundations of the building. And the other second important part is the PEB part.
Right.
The civil part always takes longer. So the foundations took about 4 months.
4
Also
months.
because the monsoon came in between. But the assembly of the PEB structure in total took about a month and a half. I'm not factoring in all the holidays and delays that happened because of many reasons. But the actual time of erecting this entire steel part, which you see above the column, above the foundation, has taken about 45 to 55 days in all.
Oh,
In all.
that's very fast.
That's very fast.
That's
yes.
very fast.
But here, of course, we are not factoring in the delivery times, we are not factoring in the delays, we are not factoring in weather
Right.
or public holidays. But the actual time of putting something like this together is about less than 2 months.
So, in comparison, had it been a conventional structure, how much time would have it taken?
Oh, it would have taken, again, if I subtract bad weather and things like that, for a span of this size, anywhere from 6 to 8 months.
Okay, all right. So there is a substantial advantage in
yes.
time saving.
Absolutely.
All right, now that we are inside, correct me if I'm wrong, this is a main frame kind of a building, right?
It's a portal frame, yes.
It is a portal frame.
Yes.
So can you just give me details about, the primary structure and the secondary structure
So
over
primary
here?
structure is what you see is being spanned from that column
Right.
to that column over there.
Okay.
And then the same thing repeating. And then connected through that girder on top.
Right.
So that is the main portal. That is one frame.
Okay.
Similarly, you erect at that much interval based on the structural design and the requirement design that you want. So here our bay is designed for the size of one studio, as I told you before. So we'll see that in a moment. So that one bay forms in both directions a space for where I can arrange my studio. Right? So accordingly to the height of the building, to the span of the building that I require, is the PEB engineered too. So why PEB and not using standard ready-made steel sections is because with pre-engineered buildings, the advantage you have is you can create all the structural elements out of plate steel and you weld them together in a factory, in a controlled environment, which is highly optimized. So also you are saving a lot on material,
Right.
and your structure is highly optimized. And then it is just bolted here. So everything here is bolted. Nothing, no welding is done at site.
And apart from this mainframe structure,
Yes.
I can see a lot of accessories over here.
Yes.
So I mean, did it take a lot of time to install all these accessories, or it was very fast?
I mean, it does take time because here you see, after what you see all in white here,
Right.
what you see hanging is what is kind of the non-PEB part, or one can say the things that are actually carrying my services. So most importantly is all my electrical lines. So the power supplies, the data cabling, the Wi-Fi, then my lighting, then my fire system, the fire alarms, and then also what you see in the large ducts here is the air conditioning.
Right.
So this all has to be designed and integrated as part of your overall building design, but also bearing in mind that those loads have to be transferred onto the main structure. So it's also a challenging part of the structural engineering. And also from the point of view of workmanship, that how do you achieve all this line and level. You also see this high velocity, so low velocity fans.
Yeah. HVLS.
High volume, high volume, low velocity, HVLS. So those fans are, because the small fans would not work here.
Right.
So all of that has been designed in a manner in which it gives even amount of light and ventilation through the entire building.
So, having chosen PB for this buildings, why did you choose Phoenix Construction Technologies specifically?
Well, quite recently, about less than a year back, I had used their system for a kind of farmhouse I had designed.
Wow.
So I was well versed, I would say, with what they can deliver. Also, during the process, I discovered that they are one of the leading PEB companies of the country. And so when this opportunity arose between the CEPT authorities and myself and few others, we approached them, and thus the building is here.
Okay, so this basically somewhere clears my misconception that PEB are only meant for large projects. You mentioned farmhouse.
Yes.
I'm sure it's a small
Very
project.
small, very small.
So it can be also used for the smaller projects?
Exactly. So that was the reason why I took that as a challenge to see if I can apply that to a domestic building.
Wow.
A very domestic building. This is the in-between domestic building.
All right.
But typically PEB, as we all know, is used in large format industrial buildings.
Yes.
Whether it's for manufacturing, logistics, storage, etc.
Yes. Yes.
So the idea was that if, as an architect, you are challenged to use such a technology, can we adopt that for domestic use? So my first project was to try it in a house, and the second now is to try and use it in an institutional setup.
Okay, that's very nice. While dealing with Phoenix, I'm sure you must have faced certain challenges. Everybody does.
Yes.
So there are a lot of phases, right from design to manufacturing to logistics to installation and so on and so forth. So did you really face any challenges, and how did Phoenix solve them?
So I think the main challenge as an architect that you feel working with a new technology and a new way of working is how do you adopt your standardized way of producing design drawings and giving it to contractors to construct. In a case like in a PEB, the architect is generally playing a role of a concept integrator, while all the drawings of manufacturing are made by the contractor, in this case Phoenix. So that is one. So what I have to learn as to how they go about making of details, how they go about fixing things, how they go about doing certain details like when you install a window in a building like this, when you install a door in a building like this, when you install air conditioning in a building like this. And all those things have to be then relooked by the architect from an architectural point of view. So that does take a little learning from both sides. And that's really the challenge. But we have, over the last course of 2-3 projects, now have a good understanding. But again, with every project, you have a new challenge. So not that this solution that I found for CEPT is applicable to the next project I may do.
Yeah.
So that is something that Phoenix also as a company was open enough to invest in, rethinking various things that they do as standard.
So you mean to say design flexibility?
Manufacturing flexibility and also designing, of course,
Okay,
because once
okay.
you manufacture a component, it also requires them to be able to design it in a way that they can command the machine to make it,
Right.
because it's all machine made.
Right.
So
Okay, Phoenix basically, has given this project from the CSR initiative.
Yes,
So, what do you have to say about that?
it's very, very kind of them to offer us a grant through their CSR to be able to make the PEB components possible. So that's very, very gracious and kind
That's
of them.
very nice.
Yes.
That's very nice. Okay, all right.
Thank you.
This morning I was reading in Times of India that the contribution of steel in the construction industry is going to increase by 10% year on year, which is higher than the GDP, which would be like 7 or 7.5%. So, I mean, what do you think about the future of steel and the PB in the construction industry, and specifically the residential sector or the towers?
Oh, it's going to be huge, huge, huge. We still have not even scratched the surface of
Right.
using steel in what we call urban construction, which is non-industrial construction. So, which is structural steel,
Right.
not just reinforcement, but the steel that we use here,
Yeah.
for example. So, it's going to be increasing multifold, and it's going to go on for, I don't know, a couple of generations more till we reach some sort of equilibrium like other Asian countries.
So, do you think that the conventional method of building, the industries or the commercial complexes or residences are going to be passé in next few years?
They all are adapting to technologies which make things faster, more accurate, and are more quality checked. So
Right.
even in concrete, if you see, there is now a big move towards going into precast concrete.
Yes.
Similarly, you see in steel, there is pre-engineered buildings or buildings which are made of kit of parts. So you see that coming in a lot because we have an acute shortage for housing, especially in the country. So everywhere we can make the demand for housing met through fast technology, through better technology, through highly quality controlled methods. Those technologies are going to definitely move very fast.
Given the green initiative that India has pledged, and concrete coming from the most polluting industry, as you would know. So, I mean, how would government look at the concrete buildings vis-a-vis the PV buildings?
I mean, concrete is not going to go away anytime soon.
Okay.
But what's going to happen is the kind of the duo of concrete and steel is going to sort of take center stage.
Right.
We need concrete because what concrete does, no other material does.
Okay.
In simple terms of engineering. So concrete will remain, but it will be replaced with steel wherever that's going to be possible. So far, steel has been seen as an expensive material or a material that requires special handling. Especially to move large components of steel at site, you require mechanical means, cranes, etc., highly skilled labor. But all of that is quietly, slowly but surely shifting, and that's a welcome sight.
Okay. One last question. What is your advice to the new budding architects?
Oh, that they have immense challenges ahead of them and extremely exciting times, and they all should engage with very interesting problems. Design actually means problem solving. Design doesn't mean just pure aesthetics and just pure style. So I hope that they kind of see that as a great opportunity and that they engage that in their professional careers and solve so many great problems that we have today in our society. So I wish them the best.
Thank you so much. Thank you
pleasure.
so much for your insights. It was pleasure talking to you, Anand bhai. Thank you.
Thank you so much.
Thank you.
Thank you.